So a sub shop offers the following choices: 3 buns, 5 cold cuts, 3 cheeses, 12 toppings, and 3 sauces. If Andrew wants a sub with 1 item from each category, how many different subs can he choose from? So one way we can set this up is the fundamental counting theorem, because we only need one of each. So the first will represent our buns, cold cuts, cheese, toppings, and then sauce. So how many choices do I have for buns? 3. This will be times. Cold cuts will be 5, 3 cheeses, 12 toppings, and 3 sauces. And so with the fundamental counting theorem, if we can choose 3 buns and you only want to pick one of them, we just multiply these together, which gives us the grand total 1,620 different subs. So same idea. A student is writing a 10-question multiple choice test. Each multiple choice answer or question, you're only going to choose one answer, A, B, C, or D. How many different sets of answers can the student give? So how could we set this one up? This is a good question because it shows you how good you'll probably do if you guess. How many different questions do we have? 10. So we have 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And for the very first question, how many choices do you have? 4. How many choices for the second? 4, 4, 4. Or, how else could we represent this? 4 to the power of 10, which is a really large number. So your chances of getting 100% if you guess is 1 in 1,448,576. So studying is better than guessing. You probably already know this, right? If you didn't know anything and you just randomly guessed, your chances are 1 in 1 million, basically, to get 100%. To pass, so you have to get, 1 in 500,000. Still not the greatest odds. You have a 25% chance. Okay. Yeah, basically. Okay, for each question. So here, 9 factorial over 6 factorial. If we want to simplify this without using our calculators, we take the larger factorial and we're going to expand it. So start with the larger one, and then we're going to expand it. So expand larger one until we get to the smaller. So how could we write 9 factorial instead? Does everyone remember what a factorial is? So 9 times 8 times 7 times. Now, once I get to 6, will I keep going? No, I could write it instead as 6 factorial. Because the rest is going to be 6 times 5 times 4 times 3 times 2 times 1 over 6 factorial. I do this because now what can we do? Cancel out 6 factorial. So instead it's just 9 times 8 times 7, which is 504. Okay, so which factorial are we going to expand here? The top one, which one specifically? Because 10 is not a factorial, so we're just going to leave it as 10 times 9 times 8. Once I get to 8, I'm going to write it as factorial all over 5 times 8. So what can we reduce out here? The 8 factorials. Is there anything else? 10 divided by 5 is 2, so we're left with 2 times 9, 18. Okay, so all of that is more to warm up for when we have a variable. So the question is here, who's larger, n plus 2 or n? Plus 2. So n plus 2 is the larger one, so he is the one we're going to expand. We always expand the larger. Okay, so we're going to write first m plus 2 times, we're always subtracting 1 from it, so what will it become? N plus 1 times, I don't need brackets, n. Now do I want to keep going and then n minus 1 or stop? Stop and we can make that a factorial. Okay, so what happens now? The n factorials cancel out. We want to solve for n. Where can we go from here now? Distribute, yeah, we want to expand it. So let's FOIL this out, or distributive law. So we're going to have n times n squared, n times 1, n, and then so we did this. Now 2 times n, 2n, and 2 times 1. Oops, what's 2 times 1? 2. Okay, what can we combine? The n's. Now what? Where do we go next? What, Brad? Well, whenever we have an n squared, you want to bring everything to one side. So whenever you have a square, make one side equal to 0, and then factor. I should write a bigger note here. So whenever you're solving an equation with a square, so if you ever have a square, make one side equal to 0, then factor. So who are we going to actually bring over then? We want one side equal to 0. The 20. So if I subtract 20, we get n squared plus 3n minus 18. And so now we can factor this guy, now that everything's on one side. So he's a simple trinomial, means that I want two numbers that multiply to something and adds to something. What are we going to multiply to? Tamara? What do we want to multiply to? Which one do we want to multiply to? It's been a while, hasn't it? Negative 18, and we want to add to, so that multiply to the last, add to the, so this is the last, add to the middle. Okay, so two numbers that multiply to 18, 6 and 3, which one's going to be positive, which one's negative? So we want to multiply to a negative, but add to a positive. Negative 3. Now I would add to a positive 3 and multiply to negative 18. So what does it become in factored form? Somebody knows. What do we do with those two numbers? Put them in. So it becomes what? N. No, our square is gone because we're putting it back in factored form. So n plus 6, n minus 3. So what would n equal to? What n? So negative 6 and positive 3. Can it be a negative? No. So in these factorials, n can't be a negative, so therefore n equals 3. always whole numbers when we're doing factorials. Jordan has 20 CDs in her car. Her CD player holds 6 CDs. How many different ways can she load her CD player? How could we set up this problem? There's a few ways. How many slots are there? How many places do we have to fill? 6. So you can make 6 dashes is one way you can set it up. 6. So you can go first one, we have how many choices? 20, then 19, then 18. Right, you can't reuse a CD. And then figure that out. The other way you can do this, does order matter here? Because we're asking how many ways can she load her CD player? Does order matter? Yes, order matters. So if order matters, what are we using? A permutation. It's a perm. And so we have 20 different CDs, and we want to pick 6, which gives us a huge number. 27,907,200. Okay, how many different ways can a director of education, a superintendent of curriculum, and superintendent of finances be selected? So how many different slots do we have to fill? 3 out of 25 candidates. So how many choices do we have for the first? 25. How many choices for the second? 24, and then 23. Or, because order matters, because they're actually specific positions, 25, pick 3. So in our calculator, how do we enter this in? Does anyone remember our permutation? Open up calculator. There you go. Isn't this a pretty picture of Edmonton? What's Edmonton? Anyways. Okay, so 25. Where do we get pick? Math. Right arrow is the fastest way. And then down to number 2, enter. Pick 3, 13,800. All right, so turn the page. Okay, did you guys look at these at all when you did permutations, pathways? Like one question? Okay, well, I'll work with you on them. They're a lot of fun. So a pathway question, if we're going from A to B, you start by going vertically and horizontally. If there's nothing feeding into it, there's only one way to get there. So that's where we're going to start with putting those as ones, like that. Okay, so now, how many ways do we have to get to this corner right here? 2. You can either come this way or this way. So 1 and 1 gives you 2. So we add up our corners. So if there was 2 ways to get to here, 1 way to get to here, how many ways to get here? 3. We add the corners, because if there's 1 way to get here, 2 to here, then there's 3 total ways to get to that spot. So again, same idea. This spot right here, there's 1 way to get over here and 2 to get here, which are the both ways feeding into it. There's 3 total. So what would this guy be right here? A 4. 3 and 1 give you 4. We just add the corners together. So So 3 and 1 would be 4 here, and 3 and 3 give you 6 there. Okay, so 1 and 4 is a 5. 1 and 5 is a 6. 6 and 4 here is 10. 6 and 4 is 10. Do you see how you fill it in? This spot, there's 10 ways from here, 10 ways from here, there's 20. 10 and 5 gives you 15. 6 for this spot, there's, whoop, that's weird. 15 and 6 gives us 21. 20 and 15 is 35. Now, this spot right here, how many roads are feeding into it? If we can only move one upwards and leftwards, there's only this road feeding into it. There's no one coming from below. And so we would just spread our 21 over here. And again, this you can only go straight up at this point, because we can't go backwards. We're only moving up and to the west, north or west is the only direction we can move. And now we go ahead and finish off the rest by using the same pattern. 21 and 35 is 56. Now the numbers get bigger. 21 and 56 is 77. 21 and 77, 98. 56 and 35, 91. 91 and 30. So finish off this guy. Gives us 126. And then 91 and 77. This is where your calculator is helpful. 168. 98 plus 168, 266. And then 168 and 126, 294. And so our final answer would be 294 and 266. So 560 different ways we can get there. There is only if it looks like just a normal square, right? But if it's a different shape, this is the only way to do it. Right, and then divide by the repeats. So if it was only like a square, so if it was just like this, and I have to go from here to here, I have to go north, north, west, 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 right? So that's like a word. So there's 5 letters, 5 factorial over our repeats, 3 factorial, and 2 factorial. So that works only if it's just a rectangle. If it's a weird shape, then that method won't work. Okay? So, because you treat it like a word, 2 norths and 3 wests, and divide by your repeat letters. So this guy, did you want to try it on your own, or do it together? On your own. Okay, give it a shot, and then we'll go over it. So you should get 180. Okay, how was that? Was that okay? Yeah? Okay. All right, so repetition of letters. So when we have repetition, we can treat it just like this idea up here. So one thing I like to do is go through my letters one at a time. So I have an M, because you don't want to miss a letter. Then I put it beside if I have A, I have a T, H, E, and another M, so I'm going to put it beside another A, a T, another T, an I, a C, and an S. Okay, so what this does for me is make sure that I don't miss a repeat. I count my letters, they tell me I have 11 letters. So we're going to have 11 factorial, so 11 different letters, divided by my repeat. So what are my 2 factorial times 2 factorial times 2 factorial? There's m's repeated twice, a's and t's. Okay, so in your calculator, what is 2 factorial? What does that equal? Just 2. So might be a little less work not doing that symbol. 11 math over, and it's number 4, divided by, I put brackets, 2 times 2 times 2. And there we go. Did you get the same thing? So remember this factorial is in math, and then probability, and then you can find it number 4. That's where you can find it. $4,989,600. You need to run to the washroom? Go to the washroom. Try and wash it out. We have an eye wash station. Okay. Okay, piano teacher and her students have a group photo. There are 3 boys, 5 girls. The photographer wants the boys to sit together and the girls to sit together for one of the poses. How many ways can the students and teachers sit in a row of 9 chairs? So how are we going to set this up? How could you draw this? So there's 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 different chairs. Now we can group them. How many boys are there? So there's 3 boys. We'll put our boys here for now. How many girls? Then there must be 5 girls, and then the teacher. So before we worry about arranging boys, girls, and teacher, we're going to deal with them individually. So how can we arrange the 3 boys? First seat, how many choices do I have? 3. So 3, 2, 1. How about the girls? First seat, 5, 4, 3, 2, 1. So 5 factorial. And how many choices for the teacher? 1. Okay, now we're not done because we have to multiply by the number of ways we can actually arrange boys, girl, and teacher. How many ways can we actually arrange them? How could we figure that out? So this first slot, how many choices do we have? There's 3 different categories. So you can either put, one way you can think of it is like this. Boys, girls, teacher, we can arrange it as. Boys, teacher, girls. Right? We could go girls, teacher, boy, girls, boy, teacher, teacher, girl, boys, and teacher, boy, girls. So how do we get 6? Well, there's 3 different groupings. So in the first grouping, how many choices do I have? The first grouping, you could either put a boy, a girl, or a teacher. So you have 3 choices. The second grouping, these things I'm talking about, we have 2 choices. Right? So we're going to multiply it by 3 factorial. Because there's 3 different objects, groups of objects that we're also arranging after. And you can see 3 factorial is equal to 6. Did you get it? Yeah. Yeah? Okay. So 3 factorial times 5 factorial times 3 factorial is our final answer. Okay, that's a really tough question and a good diploma type question because you have to remember that you have to arrange those guys too. Times 5 times 3 factorial is 6. Okay? Okay. So don't forget to multiply by the number of ways you can arrange boy, girl, teacher. Right? Because all we know is that we want the girls together, boys together, and the teacher together. Well, only one teacher. Okay. Mind if I go back to that after, Kayla? Okay. Okay, so solve problems that involve combinations. So what is a combination? When order doesn't matter. Okay. So a good example of when order doesn't matter is your cards and when you get a hand in cards. Right? It doesn't matter how you're holding them, it just matters who's in your hand, not how you arrange them. So how many ways can 6 players be chosen to start a volleyball game from a team of 10 players? So how many do we have to choose from? 10, and we want to choose 6. So on our calculator, we can find this again, math over to probability. And what number is it? 3? 4? So math, probability number 3. NCR. So we actually have to write that 10 first. Choose 6. It's 210. The town council is forming a committee of 9 men, 10 women who have volunteered. How many different ways can a committee of 4 people be chosen? Now, this is a combination because order doesn't matter. What could I say? How could I change the wording so order would matter? So it's a permutation. How would they ask it if it was a permutation? Anyone want to take a guess? What makes something a permutation? Order matters. So how could we make a situation like this where order mattered? A specific position. So one was a president, one was a vice president, right? Specific positions. Here, you want to choose 4 people. There's no specific position. So there are no conditions. Okay, so how many total people do we have then? 19, and we want to choose, if there's no conditions, 19 people choose 4. It doesn't matter if it's a boy or a girl. So 19, math, probability 3, choose 4. Okay, so there must be an equal number of men and women on the committee. So how would it look like if there are equal number of men and women? 2 men and 2 women. Okay, how many ways? How many men do we have to choose from? 9 choose 2 times, so that's the men. How many women? 10 choose 2. So it's just a pain kind of to type this in. 9 math, probability 3. 9 choose 2 times 10 choose 2. 1,620. Okay, so we're done right here. So I'm going to give you about 20 minutes to work through the practice, and then we'll go over it. So I'm going to put the timer on again, or is that too much pressure? I like the timer. If you need more, I'll give you more, but we'll go over in about 20. Yeah?